Z.ai just dropped something that nobody in the agentic coding world saw coming. Honestly, the developer community is still trying to catch up with what this actually means. We're talking about GLM5V Turbo, the world's first native multimodal coding foundation model, a system that can look at a design mockup and turn it into a complete running app, track moving objects in video, and split out precise coordinates in JSON format, autonomously browse a real website through its own eyes, and write code to recreate it. And do all of that with a 200,000 token context window and up to 128,000 output tokens per response. And the crazy part is, this model is not just another vision model with a code wrapper thrown on top. Z.ai built this from the ground up with a completely different philosophy. So let's talk about it. First, let me explain who Z.ai is for anyone who hasn't followed them closely. This is the company formerly known as Z.ai, now operating under the Z.ai brand, and as of January 2026, publicly listed on the Hong Kong Stock Exchange after raising around $558 million in their IPO. That context matters because they are not a scrappy research lab anymore. They are a publicly traded company with serious capital behind them. And GLM5V Turbo is their most ambitious product move yet. Their text-based flagship, GLM5, made waves in February 2026 with a 77.8% score on SWE-bench verified, the highest score among all the open-weight models at the time, edging past Gemini 3 Pro at 76.2%. To put that in context, the closed source leaderboard at that point had Claude Opus 4.5 leading at 80.9%, with GPT 5.2, which had been rushed out in December 2025, partly in response to Opus 4.5, pulling ahead, sitting just behind at 80.0%. So GLM5 at 77.8% was genuinely closing the gap between open weight and closed source frontier models in a way nobody had done before. Then in late March, their post-training upgrade called GLM 5.1 went even further, scoring 45.3 points in Z.ai's own internal coding evaluation that used Claude Code as the testing harness, flagging that this is a self-reported number, not yet independently verified. But even with that caveat, landing within 2.6 points of Claude Opus 4.6 score of 47.9 and reaching 94.6% of Opus performance is a claim the community has been paying very close attention to. That is the foundation GLM5V Turbo is built on top of. And GLM5V Turbo goes after a completely different problem than the text models did. Here is the thing. Most vision language models today are built in two separate pieces. A vision part that describes what it sees in text, then a language model that reads that description and figures out what to do. That pipeline sounds fine on paper, but it creates a bottleneck. Information gets lost every time you convert a visual scene into words. Spacing, pixel level detail, exact component positions, color values, layout logic, it all gets blurry in the translation. GLM5V Turbos keeps that entire step with what they call Native Multimodal Fusion. The model processes images, video, and text as primary data from the very beginning of training, not as an add-on. The vision understanding and the code generation are happening inside the same system at the same time, which sounds simple but is actually a hard technical problem to pull off without one side making the other off. The component that powers the visual side is called the CogViT vision encoder. This is Z.ai's own built vision system designed to preserve spatial structure and fine-grained detail when processing images and video. Paired with that is something called NTP, which stands for multi-token prediction. Most models predict one token at a time during output. MTP means the model predicts several tokens at once, which is faster and also helps maintain reasoning across long code sequences. When you are generating up to 128,000 output tokens of code in a single response, that efficiency matters a lot. Together, these two components support a 200,000 token context window, meaning you can feed the model an entire code base, a long screen recording of someone using an app, or hundreds of pages of design documentation without it losing track. Now, here is where it gets really interesting. Building a model that can see well is one thing. Building one that can also code well without the visual capability hurting the coding ability is a completely different challenge. The research community even has a name for this problem. They call it the seesaw effect, whose visual recognition up and code logic drips down, whose code quality up and visual grounding weakens. Z.ai solution is called 30 plus task joint reinforcement learning. During training, the model is being pushed to improve across more than 30 different task types at the same time, not one after another, not in separate stages, simultaneously. These tasks cover 5 major areas: STEM reasoning to keep the math and logic solid, visual grounding for precise location detection within interfaces, video analysis for understanding movement and changes across frames, tool use for interacting with external software and APIs, and GUI agent tasks for operating inside real graphical user interfaces. When you force a model to improve at all of these things through reinforcement learning at once, the improvements tend to hold each other up instead of trading off against each other. It produces a more stable and balanced model than training each capability in isolation. The real-world results are what made the community pay attention. On ZClawBench View, which tests multimodal coding across design-to-code generation, visual code generation, and multimodal retrieval and exploration tasks, GLM5V Turbo delivered leading results across all categories. On ZClawBench, Z.ai's own benchmark built specifically to measure performance inside OpenClaw agent workflows covering environment setup, coding, and data analysis tasks, it topped the leaderboard. On ClawEval, which tests multi-step execution and the ability to interact with real environments over many sequential actions, the results held up as well. And on AndroidWorld and WebVoyager, two benchmarks that drop agents inside actual graphical user interfaces and make them complete real tasks against massive, unpredictable screens, GLM5 Turbo also performed strongly. There is also reliability number of mentioning. Independent third-party benchmarks gave it a 98% success rate on task completion, meaning almost no technical failures even on complex changed workflows. Speed is a different story though. It sits around the 34th percentile across speed benchmarks. So this is not the model you pick when you need instant responses. It is built for depth, not pace. And honestly, the pricing context adds another important angle here. On OpenRouter, GLM5V Turbo is priced at $1.20 per million input tokens and $4 per million output tokens. Compare that to Claude Opus 4.6 at $5 input and $25 output per million tokens. For high-volume agentic workflows where you are running thousands of tool calls and generating long outputs across many steps, that cost difference becomes very real very fast. And the workflow that cost $50 in Opus tokens might cost under $10 here. That kind of ratio changes how teams think about what they can afford to run at scale. To understand why the model itself matters, let me walk through what it can actually do in practice. The first use case is front-end recreate from design mockups. You hand the model an image of a mobile app design and it reads the layout, understands the color palette, figures out the component structure, and generates a complete runnable front-end project, not a rough webfront, a working app. For high-fidelity designs, they aim for pixel-level visual consistency. The second use case is what they call GUI autonomous exploration and recreation. Working together with frameworks like Claude Code, GLM5 Turbo can autonomously browse a target website on its own, map all the page transitions, collect visual assets, understand the interaction logic, and then write code based on what it actually explored rather than just the screenshot you gave it. That is a jump from passively recreating what you show it to actively going out and figuring out what needs to be built. The third use case is code debugging through screenshots. So it a broken page and it identifies layout problems like misaligned components or color mismatches, explains the issues and generates fixed code. And the fourth is deep integration with OpenClaw. After plugging in GLM5V Turbo, OpenClaw agents can now understand web page layouts, view chart information visually, and handle tasks that combine real-world visual perception with complex execution planning across many steps. In fairness, this model has real limits. The speed sitting at the 34th percentile matters in workflows where response time is critical. It is built specifically for agentic and coding scenarios, not casual image questions or general visual conversation. Unlike every visual model right now, it can struggle with very small text or extremely low resolution inputs. There are also still open questions around how well the 45.3 GLN 5.1 ClawEval number holds up under independent testing. But inside the specific target area, agentic workflows where the model needs to see an environment, plan what to do, and execute across many states, the 98% reliability rate and the 128,000 token output capacity are real advantages that most competitors simply do not offer together at this price point. That is where we will wrap it up. The question out sitting with is whether Native Multimodal Fusion becomes the new standard for all coding models or whether the old pipeline approach can close the gap through raw scale. Drop your thoughts below, make sure you're subscribed, hit the like button, and I will see you in the next one.